Welcome to a Saturday. I haven't done anything in 2 weeks because I was working on my 3D printer. Let me flip over to a web view. And of course it's black, so we have to tell Chrome where Chrome is. Yoo-hoo, Chrome! Not that Chrome. That Chrome. So I built that printer, the Prusa I3 MK3S Plus. It took me all weekend to build it. That was not last weekend, but it was the weekend before. So solid 2 days of work and a little bit on Friday evening too. But it's turning out that this printer is outperforming the Creality printer hands down. It's definitely worth its dollar value if you just want to get up and running and printing. Now you can order this printer as a kit, or you can order it as pre-built. So I got it as a kit, saved about $250 or something like that on it. But 2 days of building, there were a couple of issues in it, in the build I didn't like. Just a sec. The instructions here are really, really good for this. It's actually just printing right now what they call a little card to identify a particular filament. You have a card holder to hold them. So I'm going to flip from this picture. So you get these two books. This is about the do's and don'ts of printing and filaments and stuff like that. But this book is how to build the whole thing, and it's really, really, really good. There were some issues. I'm afraid I didn't eat the candy yet. So this part was pretty straightforward. What I can tell you right away, don't tighten these bolts down until you get the feet, and put the feet on right away. Right? And then do their little tilty thing where they tell you to balance out before you tighten the screws down on that, because you're going to find out if you don't, you'll rock a little bit. So this is Y-axis. This is the bearings. They really fixed up the bearing thing. This used to be just a ring, like a U-ring on here. They changed that so that the bearings are more settled properly. But you have to notice that in here, there's little notches in these plastic in a lot of places. You can see it right here where they put the square washer in. They had one spot in here. After you did the Y, you're starting on the assembly of the, so this is the X, the E-axis, so the extruder assembly, where you start building it. There's this one right here. There's two holes right here for two long bolts, right? And they would tell you to put the extruder elements in first and then put the bolts in. Don't. Put the bolts in first and tighten it all down, then put the extruder in. So like this. Because trying to tighten these bolts down after the fact is really, really hard. There was another piece in here that they missed. There's a cover plate. This cover plate right here. They forgot to tell you on one of these sides to put the nuts in properly. They got all the other nuts, but they forgot one set of 4 nuts. And you find out you go to screw it in and it doesn't do anything. This is finicky. This is that sensor on the top that detects if you're out of filament or anything like that. Or the auto feed. So they have this little plate that goes on top. Where is it? Right here. This guy here. So they would have you put in that little element. Let's see, where was that page? This little heater element right here. If you tighten this down, there's a good chance the sensor doesn't work. I had to actually loosen this. I had to put a washer under the bolt to raise the circuit board. And this component right here, this black piece in the board, just, we're talking 2 millimeters higher, right? And then when I put the top plate on, this plate here, like they show here, can't do that. You can't tighten it down, because if you tighten it down, it pushes down on the board goes down, the sensor stops working. So I think that could have been a little bit better. I mean, these are a little bit minor things. Otherwise, everything else, there's a lot of cable origami involved in here. Getting all the cables right. You can see it here in these pictures. Like all this and this. So you have to, and you have to orient these bearings correctly. There's like 3 rows of tiny little bearings in a triangular shape in here. You cannot sit these bearings so one row sits right on top of the rod. They actually have to sit like this at 45-degree angles. Right? Yeah, and this is the troublesome plate here, right? That they forgot the other side of it didn't get a thing. So you have to feed all these cables through, right? And then you have to wire, tie, and you end up with this sort of effect right here. This was easy. This was straightforward. It's the front panel assembly. The heating bed was straightforward to put in. Just be careful you get all the wires correctly, because you are playing with rather strong voltage here. This is the power supply. I had a little bit of a hiccup trying to get the cover plate on here. They have this cover plate that goes on there. This was nasty. This compartment is too small. This is where the the motherboard for the printer goes. This whole enclosure could have been bigger, because trying to get all the cabling in. There's even a spot in here for doing a Raspberry Pi Zero, but I haven't done that yet, and I probably won't, even though I popped the thing off the back. But this whole thing could be a little longer and a little bigger to do this. This top part where you have to get the nylon stiffening rod that's in the cable assembly to make sure the cable doesn't flop around through here into here, that was really brutal. Getting all the cabling underneath was fairly straightforward. There was one spot in here where you're guiding the ribbon cables from the front. These things right here. They would have you here stuff it under into the rod. There was a printed thing you can get. It gives you little clips here that you can just clip in and do that. That I thought was a lot better idea. They should have included that. Otherwise, if you did everything and you ate the candy in the correct order, you would have all your candy eaten in the correct order. The calibration was pretty straightforward. I had to adjust my pin probe a little bit. That's this thing right down there. You have to get that just the right height, and you have to do it not with the metal plate on, but you have to do this sort of calibration here on the raw heat bed. So just make sure you don't have any crusty stuff in your extruder, or you ran ahead. But this was US. It was about $790. Plus, I paid an extra $150 for a spare parts kit, which included a bunch of different parts in here, including a new extruder, new probe, everything, just in case I blew anything up. Now, there is on their own site. Let's see if I can find the site again. There were some neat add-ons you could do to the printer. Let's see. I'm just looking right now. Actually, I should log in, and then I can actually go to my pick list. And I can now go to Williams. Let's see, collections, 3D models. Where is my... That's all the greater logs. Like, why can't I find my lone ones? Okay, here we go. Found them. So, there's all the things I collected up to actually look at in printing. This is the one I'm printing right now. It's these little cards. I've already printed the drawer and everything. So, this is the little drawer. And these are all the filaments I have. These are all PLA filaments. This is a glow-in-the-dark, and then these are all regular ones from dark to light. I'm printing the pink one out right now because I just got pink and purple. And I have Pet G here, and I think I'm going to start that this weekend. What else did I print out? I did print out the dinosaur. That was pretty cool. I did print the X-Wing. I don't have the right magnet for... Whoops, you're not seeing this. I don't have the right magnet for this stuff here. So, as I said, I printed the X-Wing. I printed out the dinosaur here. This one's, of course. I haven't printed these two out yet. I got all the Star Wars one. What I was looking at was these type of drawer assemblies on the side to give you storage for your tools and stuff. And I was thinking printing some of these for the rolls, to clip the rolls. This is the one I was after, actually. It's very similar to this one. It was a double, though. I haven't printed the cat out. Yeah, so this is the one I printed out, the cable assembly here. So the ribbon cable comes like this along the Prusa. That worked out really well. I also printed out this one here. Keep your fingers out of the fan. I don't know why they didn't bother just giving you one of these. But it's very straightforward to print out. They had two models, one with hexagon, another one with a different grill type. You know, I could have used this Logitech keyboard replacement foot at work a long time ago when we had so many Logitech keyboards. I'm thinking of building this one because it's a different way of doing the tensioning. It's a lot easier on the back end. They would have you do it at the center, and it's kind of weird. This was handy. This was a get your pin to probe exactly the way it needs to be, a distance from the bed. It's like a little gauge that you can use. Just remember, when you print one of these guys out, you want to print them in reasonably high quality detail, even if it takes longer to print, because you want that perfectly smooth surface and tight tolerances. I was looking at this one here, the filament guide, but I ended up finding a double filament guide that worked a lot nicer. I'm also considering this here. So, and something like this. I have the Logitech C270 camera here. I removed it, but I have it, so I could actually add this back into it and put it on here. This rattle fix that they talked about doesn't work. Don't bother with it. Now this is one I've got parts for. I haven't done this part yet. What I'm after is this part. So you change this out, and I've got this screen. I've got the Raspberry Pi. And it'll allow you to have a touch screen Octoprint / servers thing tied together with the panel. I did print out the piggy, and I have the piggy here in pink. Ta-da! One piggy. And he stands up if you prop him up properly. There we go. He has little wiggly ears, little tail. It's all hinged, printed in place, one piece. Up here's the front of him. Here's his nose. I was looking at his backside. It's kind of hard to tell, but the whole thing is done in one shot. Takes about, I don't know, just under 3 hours to print this guy in quality mode, and it printed out really nicely. So now, when I had it all assembled, do I have that here? Right, I leave it over there. I printed out the test cube, and I printed out 2 one-layer tests. I showed you a bunch of them before, and it was already by the second layer. The Z calibrations were practically perfect. I printed out the cube. It was like flawless. Like, it was a really good cube. And I printed out the benchy. And you can read the writings on all this stuff on the benchy. And it's really, really nicely done. Right? But, of course, if you have a benchy, you have to have a dry dock. Ta-da! Dry dock. Yes. I was testing different filaments. And then I decided to do this test again. I think this one came out really well. You can see where a little bit of problem in the overhang here. You can see the roughness a little bit. But otherwise, you can see this thing is really sharp. All the stuff is perfect. The printing is really good. The fine printing is really good. And I don't think I even did this on quality. I think I just did this on closer to draft mode. So we can see, if we go back to the printer, there you go. It's finished. It's a little bright. You can't read it, but it says PLA and has some gauges on it, and you can write some notes on it too. So you can say, well, this is Overture, PLA. That's why I've been buying all the PLAs, all being Overture, except for the one free filament rule that Prusa sent, which is this silver, we call with glitter in it, gray silver type with glitter. So I want to build this, the nozzle box, because I do have spare nozzles. Now, this is a bigger case for the controller on the thing. Right? Now, the reason this is in here is I'm still working on the ender. Right? Now, this was interesting. It was a right angle turn to the power cable instead of straight out the back. I haven't done this one yet. I was thinking of printing this one. This is the Raspberry Pi Zero W case. This was also kind of cool. It sits on top of the power thing. It's a little holder for parts and stuff, like screwdrivers and stuff like that. Now, I was also considering this one because this, I don't know why they make the center core of the spool holder so skinny when all the filament rolls have this big, huge hole in it. Right? I do like Creality's method. They put ball bearings and stuff in it so it spins easy and it's bigger. So it unrolls better from the thing. I did print that. This is the guide I was doing for a filament holder. So you can see them on the top right here. So it worked out really well to make these filament holders. They just clip on, and it just guides. The interesting thing is, I notice now one way you can tell sometimes a cheaper manufacturer filament, because Prusa's filament is like this filament here. You see how it's all nice and evenly rolled up? Well, not all filament guys roll like as nice and clean as that. So Let's see. I want to make the light bar. I still haven't found the light bar I like. I noticed that Prusa has a new model coming, Mega MK or something like that. But one of the things that everyone's been asking for was a light under the extruder head, so you can see what's happening under that head, right under here. That's the little part right there, right? And they listened and they put it in the new printer. I would like to make a mod for mine where I can tap the power coming off, let's say, the fan motor or something like that. I'll have to see how to do it. And put a little LED under here. And maybe even a light tube LED so it shines through a tube and the tube points out that way. I have to think about it, right? This is another one I was looking at that's pretty good. It's a filament holder with bearings, and it just screws into a shelf or a ceiling or whatever. And I got the shelves up there, and I could put a bunch of these up there and have the filaments hanging off it. Did we miss one I was thinking of? These are vertical light bars. Another spool holder. There's some S1 things in here. Oh, under the bed storage box. No, that wasn't the one. I was after not a single drawer. There was a double drawer one that I was interested in. This one. This kind of idea. So you get two drawers, and then you slide them in and blah, blah, blah. That was one double drawer one. I think there was another one that I was interested in too and doing. Could be this one here. Yeah. So they had two drawers on each side. You can change this drawer. You don't have to have the hexagon through it. You can have solid if you want. You can change it. So I thought that was kind of cool. So as you see, there's a bunch of little printable projects I can do here. Now I did try to print those drawers out, but all the profiles and that are all rigged for PETG instead of PLA, and I couldn't get it successfully trying to convert it to PLA. I missed some variables in the slicer. They still thought it was doing a PETG layout, so some things were off. So, but I do have bags of PETG sitting on the floor, different colors, so including orange. And this is the one I could have used at work a long time ago. It's the cable tag printing thing. It just slips onto cables like that. And I thought that was pretty cool. It's like this. And then around here, yeah, a battery dispenser. Yeah, that would be good. And this one, it was handy. I was looking at this one because I kept not figuring out how to do an easy pick of metric bolts, right? So the idea behind this, right? You just drop the bolt in place and it tells you what it is. What the nuts are. Yeah, so. This is another one variant of it. These are more variants of clips. This looks interesting too. The fast printing modular drawer system. But there are so many things to print and so little time to print them. That's right. So that was the piggy, that was the dad, that was the benchy, and the benchy dock. So we do have some stuff. So we'll start on that. This is the panel from, oh, you're not even seeing this. Let's try this again. This is the panel for that's on that mod for the Prusa. So I happen to have a knife here. So this is it. Maybe need a little more brightness in here. Let's try the brightness thing. There we go. So Raspberry Pi goes on the bottom of this, or equivalent. This goes to the GPIO pins. Interesting. But yeah, so that'll go on the side, and I believe it's touch sensitive. I've got all the parts for it here. So this guy goes on the Pi's pins, and this goes into here, blah, blah, blah. You get the idea. So that's for that project. I'll put these in here. So this was now I was looking at how to figure out how much pressure the head is putting on the bed when you're trying to do calibrations, right? Because the piece of paper is just not working. So this little guy here is one of a few I bought. These is a pressure sensitive resistor. I think they're called FRS or something like that, force resistive sensor, something like that. And the idea is you hook them up to a microcontroller, and you can, when they're down like this, pressure put on them like this, it'll tell you how much force you're putting on, up to a certain point, of course. Like they're not unlimited, so to speak. Now, I don't have a limited supply of Raspberry Pi Zeros. And they really didn't want to waste one on Octoprint. So these guys here, and now it's a little too bright, Liberate Computing Board. Right, like this. These are 2 gig of memory. And storage is the usual SSD, or, and I already ordered it, but I don't have it here, is the EMMCC, right? So it has a lot of this exact same footprint, same holes as the Raspberry Pi Zero, and I believe the GPIO is laid out exactly the same. There's just some different stuff in here, right? But right down here, in here, this little thing, is a very tiny connector, and an eMMC card goes right here. So I ordered some 32 gig cards to snap onto these boards. So in essence, I don't even need an SSD in here. It all can be loaded into here. So I'm thinking that maybe I can get, and I found the instructions for putting Octopi on here. This actually uses pretty well the stock Bullseye distro for Raspberry Pi in here. So it all works. So these weren't very expensive. They were, I don't know, about Canadian. They were about $50. So that was pretty good. And I have 2 of them here. So I can make 2 different Octopi servers basically from them. Now, last time I had those little ESP with the screens on top, but on the bottom side was the batteries. They used a type of lithium battery that I didn't have. Well, I now have them. So these, ta-da, are these guys. kind of like the 18650s or whatever, the other ones, the big long ones. But these are smaller ones, and they fit under those type of controllers. And I have some other separate battery holders for them too. Now this one is extremely light, and this is another FSR sensor, I believe. Yep, so this is a different board, but it also has another sensor here, right here. So it's a different one from the last one. And what's in here? Oh, there's something in here. Oh, there's a bag within a bag. Okay, I get the idea. So one bag holds the sensor, and one bag is holding the board. It's like a static bag within a static bag here. Yeah, see? Just to keep them together so you know you're putting the with. Now, I know Adafruit has some of these on their site, but I didn't see any ones I kind of liked. So, what was this again? I think this is another sensor, FSR sensor. Yes, it is. And a different board again. So, I think this guy is using very basic stuff. Like this is like the equivalent of all these sensor kits where you have these 3-wire things, power, ground, and a data line to read whatever's coming off the sensor. They're not I2C and they're not SPI. They're just really dumb versions of things like that. So... So I got my friend one of those these starter kits with the Pico, and he really liked it. So I got a couple more of them, but without the Pico, because I have Picos here because they were cheaper without the Picos. Now, these are the ones for the Raspberry Pi Pico. So they're complete kits, so I can put them together and give them to people. And I think I'll put it down here. But this one is a little different. This guy here is not a Pico, if I can actually figure out how to open it, because it's a adult-proof box. Where's that child when you need it? Dad, I can open the box. Well, yeah, sorry. So, we don't need this piece here. So, this kit, same idea. Which is the top? This one. Okay. There we go. Same idea. Same company. Oh, nice resistor card. Woo. What else you got? Safety User's Guide. Be safe, don't use it. Jumper wires. But guess what we get with this one? An ESP rover with a camera. Right, in the kit. And a little breakout and some other parts in here. And a breadboard, of course. Actually, not a bad breadboard. Let's put this band back on here. There we go. But there you go. And a little cable. This is oh, this is cute. This is a breakout thing for this, but designed for a breadboard, and you can do power in here. So, power. Interesting to give me the wrong one. They should have given me the cable that goes into there. That's okay. That's not a problem. You can see under here that it looks like there's a bunch of circuitry in here to pass the power. So 3 volts and 5 volts. But let's see what else we got in here. Oh, very heavy. This is unopened from Amazon. One thing I ran into in assembling the Prusa printer, I lacked certain tools. So I decided to go get some. First of all, a set of better Allen keys. You know, bigger ones. Hey, what's this? A cleaning, polishing cloth. Ooh. So, I mean, these are a dime a dozen on Amazon. I just picked one that looked nice. So, let's see. Get this back in its kit. And get this one back in. So, of course, I don't need the really big ones, but I'm at the more the tiny side here. But there we go. 15 metrics. 15. What I really was after on some of these is, especially on certain sizes, longer, you know. I'll see how these work. I almost wish there was a little more on the small side, but hey, beggars can't be choosers, right? Or is this something like that? Okay, I have no idea what this was again. Oh yes, battery holders and other stuff. That's what this is. So those batteries I got, these are the equivalent of the bigger battery chargers, but they're the little guys. So this is a Signal, one of, so like this. It's the same idea as the other ones, except this is the small version. So you put your battery in here, you charge it up, right? Input, you provide some output, or you solder on some double headers here, 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 and here, here, and you got some 5 volt, 5 volt, 5 volt, 3 volt, 3 volt, and a little on-off switch, right? And all the stuff on the bottom here is to help you charge it smartly so you don't screw it up. That's what all these guys are. This Signal, like so. And I'm not saying signal as in this signal. I mean signal is a single of, one of. And these are doubles. I was hoping to find a quad, but I didn't see a quad. But I think that'll work out quite well. Another Amazon. This was another tool I really, really needed. And I had them at work, but I didn't have them here. Little wrenches. So, mostly I needed the metric side. You believe doing those little nuts and stuff like that on the printer? I could have used one of these. Man. But there we go. Now I have a set of these. I have a set at work, but I think they're only Imperial. I can't remember. They're either only Imperial or only metric. This is a double set. And then you can put them on here on a big ring. And I guess to give you a couple extra bags just in case you need a new bag, your Eureka bag or something like that. But that's definitely something I needed. I think that's the last item. I somehow, I think, double ordered on something, and I can't remember what it was. But these are S3 displays. Oh, okay. I know what these are. I have S2 displays. Let's do it that way. And cut the tape here. Let's do the other one because it also has this. We'll cut it here. And we'll cut it here. And we'll peel it off. Close that one. Oh, there it is downstairs. Okay. There we go. And we'll just get rid of this trash here. So these guys here are... Ooh, these are nice looking. Wow. LilyGo, I have to admit, does a pretty darn good job on their stuff. So, that's interesting. What they've done these nice little plastic inserts here to hold the screen instead of a piece of foam. That is nice. So we've got a battery. We've got I2C, I think, right here. We've got a reset button over here. We've got an alternate antenna if you don't want to use the internal. Technically, there's pins here. So you could pin this. Be a bit tricky on the soldering job. Unless you can pop off the plastic and the screen carefully. I'll have to figure this one out. I think I could solder this. It'll just be really tricky soldering. But I could get a pin set onto here so they could go onto a driver. Yeah, we'll have to see. And they do supply under here the battery connector and the pin. Yeah, they do supply the pins. So, I mean, the idea is this. You can barely just see them. I'm just curious. Yeah, the plastic is fastened down by a piece of double-sided tape. If I was very, very careful, I probably could get it off. So, we'll have to see. What, they put tape on the backside? Yeah, they did. There we go. I'll have to catalog all that stuff. But yeah, so my biggest thing in the last 2 weeks is just all 3D printer. Print, 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 print. So, let's see. By the way, this is Octoprint, if you've never seen it before. So you can actually see your object as being printed, for example. So that's what the sheet will do. See, these are the layers. Like so. 1, 2, 3, 4. Because that's what the slicer does. It just slices it into layers and then prints the layers. Now, I haven't tried out, because I haven't got the camera I want to use, is things like Octolapse and the, there is this one too, time-lapse, right? What it does is something like every layer, it does a snapshot, and it stitches all the video together basically automatically, and then you end up with this time-lapse photography. This guy here is kind of cute. This tells you how offset your bed is, how bad it is. Right? So this is my current bed, for example. Right? I could update the mesh. Let's see. Whoops. I left the object on the bed. It's not going to like me. Not a good idea to leave a print object right in the middle of the calibration head. But you can see, for example, that this would be the front of the printer right here. That's the corner you see. So you can see this corner up here is off. There's a height difference. This corner here is pretty good. This corner here is not bad. It's this corner here that has the real trouble. But it's not as bad as you might think. I mean, 0.34 is not as bad as it could be. It is into the orange a bit. It could be a little lower. There are techniques you can do. You can change out under the bed, for example, the spacers. Instead, you can replace them with a spring system that someone else did. And you can get this a lot closer to being like all green, for example. That's ideally what you want, is you want this bed to be all green, right? But that's what the whole point of the mesh map is, and that is to compensate for this sort of thing while you're printing. So it'll take this into effect. If it's printing toward this corner, it knows it has to compensate the head by 0.34, plus 0.34 Z, right? Or this one, 0.01. So you can even, I think someone was demoing, you can actually dump this stuff into a more sophisticated piece of software and get actual compensation numbers you can actually put into a control file. Like if you were using Clipper, for example, you could do this and then use Clipper's control files to fine tune this so it's really, really accurate. But I haven't gotten that far yet on this. So at the moment, there's just a really cheap camera sitting in. I want to put that camera mount for the C270 on here. Then it would be a lot closer looking. But you can see down here in this corner right there, there is that's that measuring gauge for the sensor. Those little round yellow things there, those were the ones I tried to, because those threaded thing is not tight at the top, so it can vibrate a little bit, so you end up with this noise from the printer. I was trying to make the printer a little more quieter. It's pretty quiet as it stands compared to the Creality, but it's still certain movements and stuff like that will generate noise. I mean, it's probably expected, but yeah. So let's see. I think I'll leave it at this, and I am going to today try some PETG out on the printer probably. So I want to see if I can print some of that components for the front, for example. As I said, I tried before to print some of the stuff, and it wasn't printing. So especially the drawer stuff. I wanted to try that out this weekend, see if I can actually print the drawers correctly. So we'll find out. But in the meantime, have fun. And get yourself a 3D printer. It's really, really fun.